As we have seen with stars and bars representation, in a general sense, coming up with a representation in a combinatorial problem is crucial because sometimes which method to apply can be just inferred from the question, but sometimes it's not that obvious. All right. So if you can come up with a representation so that you actually transform the problem from its given form into some other form that you actually know how to solve, it becomes much easier. So to be able to do that, you should be able to come up with representations for the solutions of a problem. Here's a simple example. You have a rectangular grid here, let's say a Cartesian grid. So this is 1 0, this is 2 0, this is 3 0, this is 4 0, this is 5 0. For instance, this point here is 3 2. Okay, so you have this grid and you would like to find the number of paths from 0.00 to 0.53, but you have to make sure that in your paths you can only move to right or upwards. So for instance, you can go like this, or you can go like, for instance, up towards and then right and then up and then right here. Or you can just go like this, or you can go like this, or you can go like this and then like this and then this and this. But for instance, let me use red here. You cannot go like up and right and then down and then right and up and right. So you can't go down, you can't go left, you can only go up or right. So the question is, how many distinct paths are there from 0, 0 to 5, 3? And then can we generalize this? Now you see, since I'm allowed only two types of steps, let's say, I can only go right or up at a certain point. So if I'm here, I can go either like this or like this. If I'm here, I can go like this or like this. If I'm here, I can go like this or like this. Okay? So at every point, wherever I'm along the path, there will always be two options among me, okay, in front of me. So, and from a big picture, you see there are 5 steps towards right and 3 steps upwards that I have to cover to reach the point 53 from 0, 0. So essentially, what you need to do is take 8 steps, and among the 8 steps, 5 of them has to be towards right and 3 of them has to be upwards. Now if I, for instance, represent the upward steps by ones and the right steps, okay, the steps towards right, as zeros, then this means I'm going to represent each path as a binary string that includes 5 ones and 3 zeros. Okay, so for instance, this is the path where, well, I have assumed it's going to be 3 ones and 5 zeros. Why? Because I have assumed the upward step is 1. So this binary string corresponds to 3 steps upwards first and then 5 steps towards right. Or if you write 0, 1, 0, 0, 1, 1, 0, and 0. This corresponds to a 0 towards right and then 1 towards up and then 0 and then 0 and then 1 and then 1 and then 0 and then 0. okay? Or for instance, 1 0 0 1 0 0 1 0. So this is 1 0 0 1 0 0 and 1 0. Okay, so what this uh, is a representation of every path. For every path, there exists an 8-bit binary string that has 3 ones and 5 zeros, and vice versa. If you give me a binary string with 5 zeros and 3 ones, I can find the corresponding path. Or if you give me the path, I can find the corresponding binary string. So there's a one-to-one relationship between the two. All of the paths are going to be 8-bit long in this representation, and it will have 3 ones in it and 5 zeros in it. So now this has boiled down to selecting which 3 bits to make 1 out of 8. So the answer to this is clearly 8 choose 3, or equivalently 8 choose 5, because the equivalent question is which 5 to make 0. It's the same problem. So essentially, if you generalize this to point m and n, that will be m plus n choose m, or m plus n choose n. The same problem. You can also have variations on this. How many paths are there from 0, 0 to mn that passes through m prime, n prime? Let's say this is mn, and let's say this point here is m prime, n prime, somewhere in between. So now this question gives you actually a procedure where you need to have two tasks. From 0, 0, you first reach m prime, n prime, and then in the second task, you start from m prime, n prime, and you reach mn. So you just apply the same approach to this question. From here to here, I can get in m prime plus n prime, choose m prime ways, times, due to product rule. From here, I shall go to here, or I can do that in how many ways? And the distance here now is in horizontal, that is m minus m prime. In the vertical, that will be n minus n prime. So add them up, m minus n prime plus n minus n prime, choose, well, let's say m minus n prime, or I can have used n minus n prime. Okay, so this is the number of ways to go from 0, 0 to mn that pass through m prime, n prime.